You finish dinner, clear the plate, and close the kitchen. An hour later, your hand is back on the cupboard door. The wrapper says the portion was enough. Your body did not get that message. By bedtime, the empty packet is beside the first one, and you are wondering when the choice was made. Maybe your version happens at a desk. The crumbs collect beside the keyboard while your attention stays on the screen. Maybe it happens in the car, where the bag feels nearly weightless until your fingers touch the bottom. You remember opening it. You do not remember deciding on every bite. Now picture that small moment repeating at breakfast, lunch, and dinner. Nothing looks dramatic, but the quiet gap between the food you planned and the food you actually ate keeps opening. Your belt catches one notch sooner. The number on the scale drifts. You blame your discipline because the label looked reasonable. That blame lands on the wrong person. Calories still count, of course, but a calorie number printed on a package does not tell you how much food you will choose when you are free to keep eating. The sharper question is, what happens to intake after the menu has been set? The evidence is mixed, and that is worth saying before we touch a single headline. There is one small randomized inpatient trial. There are also large observational studies and reviews that follow patterns in ordinary life. A formal review graded several major links, only moderate in certainty. Its authors could not yet separate processing itself from poor overall diet quality. That mix gives us different kinds of truth. A controlled trial can isolate a short-term difference under unusual conditions. A cohort can show whether a pattern travels with people for years, but it cannot balance every part of their lives. A review can combine the record, though it inherits the weaknesses of the studies inside it. Keep one image in mind. 2 meal trays sit under hospital lights. 5 cards beside them show matching calories, energy density, fat, sugar, sodium, and fiber. One tray belongs to the strongest test in this entire story. I will show you what happened when people could eat as much or as little as they wanted. But first, you need the 4 clues that make that result honest instead of sensational. Do not guess which tray held less sugar. That card was already matched. Do not guess which one held fewer presented calories. That card was matched too. The open question sits beyond those totals. It is the amount a person chooses after the tray arrives, and nobody tells them when to stop. I went looking for a clean villain. The papers would not give me one. What they gave me was more useful, a way to tell a causal test from a worrying pattern, and a way to stop turning food into a morality play. So we are counting down 5 findings about ultra-processed food. Each one answers 2 questions. How much confidence does it deserve? What can you do with it without pretending the science says more than it does? Number 1 is the ordinary hospital meal that made the matched menu behave very differently. Number 5 is the confidence label. It sounds dry. It may be the most protective item on the list because it keeps a frightening association from becoming a fake certainty. You already use confidence labels outside science. A dark cloud may be worth carrying an umbrella for, even when rain is not guaranteed. You change the size of the response to fit the strength of the signal. Food evidence deserves the same calm habit. Concern can be reasonable without pretending uncertainty has vanished. A 2025 umbrella review pulled together 16 publications that had already combined many studies. The reviewers used GRADE, a formal system for rating how sure we can be that an estimated link is close to the truth. They found moderate certainty for all-cause mortality, cardiovascular disease, type 2 diabetes, and colorectal cancer. Moderate does not mean meaningless. It means the link is serious enough to study and act on with proportion, but future work could still change the estimate or the explanation. In that review, each additional 50 grams a day was linked with a summary mortality risk ratio of 1.02. For diabetes, each 10% increase in the diet was linked with a risk ratio of 1.12. Notice that the units change with the outcome. One estimate is tied to grams per day, the other is tied to a percentage of the diet. They cannot be stacked into one personal score. They are summary comparisons from different bodies of evidence, useful for seeing a direction and poor tools for predicting your next year. The detail most people miss is printed in the review's own conclusion. The authors said it remains unclear whether processing raises risk or whether ultra-processed intake mainly marks a poor quality diet. That closes the first small loop. The category can predict risk before science knows which feature deserves the blame. Use that finding as a confidence dial. When a headline says ultra-processed food causes a disease, turn the claim down one notch. Ask whether the evidence is a randomized test, a cohort that follows people, or a snapshot taken once. You are not dismissing the warning, you are putting the right weight on it. Say the sentence in a more accurate form. Higher intake is linked with the outcome in this kind of study. That small change protects the causal question. It also protects you from the opposite mistake, where uncertainty becomes an excuse to ignore every consistent signal until a perfect decades-long trial somehow appears. Many people watching this channel have already tried to control intake with a fasting window. How long did your longest fast run? Drop the number. I am curious how this audience splits. Number 4 is the border problem. Before a study can count ultra-processed food, someone has to decide what belongs inside the category. That border is much less settled than the confident red graphics in news stories suggest. Stand in a supermarket aisle and the problem becomes concrete. A loaf, a sweet drink, a frozen meal, and a protein bar can all be placed under one broad heading. The heading helps researchers count a pattern. It does not make those foods identical, and it does not reveal which shared feature matters. A 2025 systematic review found 6 classification systems. They are called NOVA, EPIC, IFPRI, UNC, UP3, and SIGA. None clearly specifies which processing techniques make a food ultra-processed. Only SIGA adds numerical cutoffs for sugar, fat, and salt. Think of a map with a thick border but few road signs. Researchers can often agree that a product sits in the territory. They cannot always point to the road that carried it there. Was it the industrial technique, the nutrient profile, the ingredient list, or some combination? The systems do not settle that question. This is why arguments about one borderline food can swallow the whole conversation. Two people may use the same category name while relying on different cues. One notices additives, another notices packaging, a third notices nutrient cutoffs. If the rule stays hidden, the disagreement looks scientific even when it began as classification. The review's practical conclusion was blunt. Current systems are usually not suited to identifying which factors in these foods may be harmful. So the category is a screening question, not a verdict on every product inside it. The pro tip almost everyone gets wrong is treating the label as a toxin stamp. Use it as a prompt to turn the pack over. Look at what the food is, what else is in it, and how much of your routine it occupies. The word ultra-processed begins the inspection. It does not finish it. Make the inspection specific. Is this something you eat once a month, or the base of 2 meals every day? Does the category tell you what feature you are trying to change? If you cannot answer, pause before replacing the product with something that wears a cleaner image but serves the same role. That closes the border loop. A fuzzy definition does not erase the pattern. It limits what the pattern can explain. The match trays are still waiting, and their lesson will be stronger precisely because we have not forced every packaged food into one moral bucket. Number 3 is the long shadow. This is where the evidence leaves the controlled ward and follows people through ordinary years of shopping, eating, working, and aging. The advantage is scale. A ward can control meals for weeks, but it cannot watch hundreds of thousands of lives unfold for 19 years. The weakness is control. Real lives carry thousands of differences into the data, so the long view gains reach while losing the clean comparison of a random assignment. A 2021 systematic review and meta-analysis combined 13 prospective cohort studies with 183,491 participants. Follow-up ranged from 3.5 to 19 years. People in the highest ultra-processed intake groups had an all-cause mortality risk ratio of 1.25 compared with those in the lowest groups. In plain language, the heaviest users died about 25% more often during follow-up. That is an association, not proof that the processing caused each death. People who eat differently may also differ in income, sleep, smoking, healthcare, or countless details a study cannot perfectly balance. The comparison also uses the ends of the intake range. It does not say one packaged lunch produces that result. It compares the groups with the highest and lowest consumption as the original studies defined them. The distance between those groups may represent an entire way of eating rather than one decision. The same review found signals for cardiovascular disease, cerebrovascular disease, and depression. In cross-sectional snapshots, the highest intake was also associated with 39% higher risk of overweight or obesity and 39% higher risk of a high waist circumference. Those waist figures deserve one break. A cross-sectional study measures the diet and the outcome around the same time. It cannot reliably tell which came first. The image matters because the waist is where this research becomes visible, but the timeline remains uncertain. Someone may change what they eat after gaining weight. Someone else may gain weight after a long change in eating. A single snapshot can capture both people in the same frame. That is why the result can support a warning about a pattern, but cannot narrate the direction of one person's story. One thing to never do is convert a relative comparison into a personal forecast. A risk ratio of 1.25 does not mean ultra-processed food gives you a 25% chance of dying. It compares rates between groups in the study. Your starting risk and your full pattern still matter. That closes the long shadow loop without throwing away the warning. Use this clue at the level where it was measured. Look at the pattern, not the single biscuit. For 7 days, notice how many eating moments arrive mostly from products in the category. You are taking an inventory, not diagnosing yourself, and not declaring a food forbidden. Write down the moment, not a calorie total. Breakfast in the car, lunch at the desk, a packet after dinner. The exercise is meant to reveal repetition. It is not a dose, and it is not a medical test. Once the repeated slots are visible, you know where a practical experiment could begin. The stakes now rise. The first review showed a long association, but people with the highest intake may differ in many other ways. Number 2 asks whether the signal survives when researchers adjust for some of the obvious nutritional differences. In 2019, the Nutrinet Santé cohort followed 105,159 participants for a median of 5.2 years. People repeatedly recorded what they ate across 24-hour periods. Each absolute 10 percentage point increase in the ultra-processed share of the diet was associated with a cardiovascular disease hazard ratio of 1.12. A hazard ratio compares how often an event occurs over time between groups. It is not a statement that 12% of participants develop disease. The number 1.12 describes a relative difference tied to that 10-point increase after the researchers followed the recorded diets and counted new cardiovascular cases. The association also appeared for coronary heart disease and cerebrovascular disease. More important for our question, the overall cardiovascular result stayed statistically significant after adjustment for saturated fat, sodium, sugar, fiber, and a healthy dietary pattern. Adjustment is like trying to level a tilted table. Researchers account for measured differences, so one side is less likely to lean because of salt, sugar, fat, fiber, or the broader diet. But they cannot level what they did not measure well. The study's authors said causality still had to be established. That last sentence is not ceremonial caution. People are not assigned to years of eating in this cohort. They choose their food, and those choices travel with culture, time, money, work, and health. Statistical adjustment can reduce several imbalances. It cannot turn all those lives into copies of one another. The small change that does the most is reading the unit correctly. This was not one snack, one dinner, or one ingredient. It was a 10 percentage point increase in the share of the whole diet. A product can be in the category without moving your pattern by 10 points. Frequency and proportion are the real scale. So use number 2 as a pattern audit. Pick one repeated slot, perhaps breakfast on workdays or the snack you eat without a plate. Ask what share of that slot comes from packaged formulations. Changing the question from good food or bad food to repeated share makes the choice visible without turning it into shame. You might find that the category barely touches dinner but fills every rushed morning. That is more useful than a dramatic pantry purge. It points to one stable place where you can compare options. It also keeps an occasional food from carrying the blame for a pattern built somewhere else. That closes the adjustment loop. The association did not vanish when several nutritional measures were considered. It also did not become a randomized experiment. We have reached the line that observation cannot cross, which is why those two covered trays matter now. By this point, both parts of the evidence should be active in your mind. The long record raises the stakes. The uncertainty about category and cause sets the guardrails. Only a randomized comparison can move the causal question forward, even if that comparison is small and short. Number 1 is the only randomized test in the facts behind this episode. It took place inside the NIH Clinical Center, where 20 weight-stable adults lived while researchers controlled the menus. The adults had a mean age of 31.2 and a mean body mass index of 27. They were randomized to an ultra-processed diet or an unprocessed diet for 2 weeks. Then each person crossed immediately to the other diet for another 2 weeks. That crossover matters because every participant experienced both conditions. Now lift the covers from the trays. The 2 diets were designed to match the calories presented, energy density, macronutrients, sugar, sodium, and fiber. Those were the cards beside the meals. The instruction was simple: eat as much or as little as you want. This is the title moment. On the ultra-processed diet, people took in about 500 extra calories a day and gained weight. The menu started equal on paper, but appetite landed somewhere else. The menu starts equal, but appetite lands elsewhere. That is the spine of the whole episode, and it is much more precise than saying every processed calorie behaves differently inside the body. The diets changed free intake in this trial. The paper does not grant us permission to invent the missing step. About 500 calories is not a rounding error. Across a day, it can hide in the distance between the first serving and the moment you stop. The participants were not ordered to overeat. They were given free access to the matched menus and their intake separated. Randomization changes what we can say. In this short inpatient setting, the ultra-processed diet caused higher calorie intake and weight gain compared with the unprocessed diet. But the trial does not tell us that every product has the same effect. It also does not identify the one feature responsible for the gap. That distinction is the awe in the result. Researchers matched the obvious nutrient totals and still saw intake move. So the nutrition label was not the full behavior of the meal. Something about the diets as served changed how much people consumed, even though this facts file does not justify naming the hidden lever. The detail most people miss is that calories were matched as presented not forced into each person. Had everyone been required to eat the same amount, the study would have erased the very behavior it was testing. Free choice was not a flaw. It was the measuring instrument. That closes the final small loop. It also closes the master image, 2 trays, matching cards. About 500 calories of separation once people ate freely. The strongest evidence here is not a claim that processing is poison. It is a controlled warning that foods with matched headline nutrients can produce very different intake. Use that result as an environment question. Which repeated meal makes it easiest to keep eating without noticing? Put that food on a plate before you begin. Keep the package out of reach while you eat. Compare your stopping point with a less processed option on another day. Treat the result as information about your routine, not proof about your biology. 4 rules keep this countdown useful. First, ask what kind of evidence you are hearing. A randomized trial tests cause more directly than a cohort. Second, read the unit. 50 grams, 10% of a diet, and highest versus lowest groups are not interchangeable. You can apply those questions in under a minute. When a frightening headline appears, find the study design and the comparison. If both are missing, the headline has removed the 2 details you need most. Put them back before you decide whether the claim deserves attention, action, or simple patience. Third, read the timescale. 2 weeks in a clinical center answers a different question from 19 years of observation. Fourth, keep category and mechanism separate. Ultra-processed is a useful flag, but the current definitions do not tell us which technique or feature creates harm. The final rule is the one that protects your next grocery trip. Change a repeated pattern before chasing a perfect label. One ordinary breakfast or snack that appears 5 times a week matters more to your routine than a rare food you enjoy without guilt. Line the pieces up and the shape is clear enough. The long studies connect heavier ultra-processed intake with mortality and waste outcomes. The Cardiovascular Association survives several adjustments. The category itself remains fuzzy. Then the controlled trial shows the hardest fact. Matched presented nutrients did not produce matched intake. Go back to that cupboard door after dinner. You do not need to call yourself weak, and you do not need to fear every package. You can make the invisible intake gap easier to see. Start with one eating moment that repeats. Give it a plate, a pause, and an honest comparison. You can trace every number in this video back to a linked paper below. They are listed in the description in the same order as this countdown, so you can check the methods and the limits for yourself. This is education, not medical advice. Use it to prepare a better question for your doctor, especially when a diet change could affect medication or ongoing care. Before long, I look at emulsifiers properly, not in passing. That is where we can ask whether one proposed feature of processed food holds up when the category is taken apart.